Welcome to this specialized training module on information systems operations, focusing specifically on operational log management. In the realm of IS auditing and security, if it wasn't logged, it didn't happen. Logs provide the critical trail of evidence for troubleshooting, security incident response, and regulatory compliance. Today, we will explore the life cycle of a log, from generation to archival, and how to effectively manage and audit this massive stream of data. Let's get started. Let's begin by defining our scope. Operational log management is not just about keeping text files. It is the systematic control of data recording events within your IT environment. As noted in the sources, log management is crucial for identifying and troubleshooting issues, ensuring system security, and maintaining compliance with regulations. Think of logs as the black box of your organization's aircraft. If a system crashes or is hijacked, the logs tell us what happened. The objective is to capture a complete record of who did what, where, and when. Without this visibility, an organization cannot effectively detect unusual activities or respond to security incidents. From an auditor's perspective, we are looking for assurance that this process is robust and continuous. This mind map visualizes the central role of log management. Branching out, we see its three primary values: security, for detection and forensics; operations, for fixing broken things; and compliance, for proving you followed the rules. The bottom branch reminds us that these logs come from everywhere: servers, routers, and software applications. What exactly goes into a log? According to the ISACA resources, a typical log entry contains 5 critical pieces of information: the date and time, the type of event, details such as user IDs or file names, the source of the event, and the outcome. We categorize these into specific types. System logs tell us about the health of the OS. Application logs track what the software is doing. Security logs are vital for tracking authentication, who logged in and who failed. Finally, audit logs track changes to the system itself. As an auditor, you must verify that these specific details are actually being captured. A log that says error occurred without a timestamp or user ID is useless. Here we see the structure of a log entry. The base class log entry contains the mandatory fields: timestamp, event type, source, user, and outcome. Extending from this are specific types like security log tracking logins and system log tracking hardware. This structure ensures consistency across all log sources, making analysis possible. Managing logs is a lifecycle process. It starts with generation at the source. Then comes collection. We cannot leave logs on individual servers where they can be deleted by an attacker. We must collect them. Storage is next. We must keep them secure. Then comes the value-add phase, analysis. This is where we turn raw data into intelligence. Reporting provides the dashboard for management. Finally, we have archiving and deletion. You cannot keep everything forever. Policies must dictate when data moves to cold storage and when it is destroyed. Missing any step in this cycle breaks the chain of custody and utility. This flow shows the linear progression of the log lifecycle. We start at generation. We move to collection and storage. Note that analysis happens while data is in storage. From analysis, we report. Eventually, data ages out to archiving, and finally, reaches the end of its life at deletion. This lifecycle must be documented in your policies. In any modern environment, the volume of logs is overwhelming. Manual review is impossible. The solution is centralization, often using the syslog protocol to forward logs to a central collector. We use SIEM security information and event management systems. A SIEM does more than just store. It performs event correlation. It connects the dots. For example, it might link a badge swipe at the front door with a login attempt on a server to validate identity, or flag a login from an unusual country. SIEMs provide real-time alerts, turning millions of log lines into a single, actionable warning for the security team. This diagram illustrates the SIEM architecture. On the left, we have various sources: firewalls, servers, and applications. They all push data via syslog to the SIEM collector. The collector feeds the correlation engine. If a pattern matches a threat signature, it branches to alert security team. If not, it flows to store for audit. This automation is the only way to manage the data flood. Logs are evidence, and evidence must be protected. A savvy attacker's first move after a breach is to wipe the logs. Therefore, we must implement strict protections. We often use worm storage, write once, read many, so that once a log is written, it cannot be changed or deleted, even by an admin. We must strictly control access. Auditors read, admins read, but nobody deletes. We also need encryption encrypting the logs, as they travel over the network to the SIEM and while they sit on the disk. Integrity checks, like hashing, ensure that if a log file is altered, we know immediately. As an auditor, you verify these controls are active. Here we visualize the defense of the log repository. An attacker attempts to delete or read the logs. They are stopped by 3 layers of defense: worm storage, preventing deletion, encryption, preventing reading, and access control, preventing entry. The result is that modifications are blocked and data remains confidential. This defense in depth is mandatory for log integrity. Storage is not enough. We need action. We must move from reactive storage to proactive monitoring. This involves establishing a baseline. What does normal traffic look like? Once we know normal, we can detect anomalies. A critical challenge is alert tuning. If the system screams about everything, the staff stops listening. That's alert fatigue. We must tune the SIEM to alert only on high-fidelity indicators of compromise. These alerts should feed directly into the incident response process. If a critical system service stops or a malware signature is seen, the logs trigger the alarm that deploys the team. This sequence shows the monitoring flow. The system sends an event to the SIEM. The SIEM compares it to the baseline. If it's normal, it archives it. If an anomaly is detected, it triggers an alert to the analyst. The analyst then investigates the system. This feedback loop ensures that only relevant events consume human attention. How long do we keep this data? That is defined by the retention policy. This isn't a guess. It's driven by regulations. PCI DSS requires 1 year. HIPAA often requires 6 or more. You must balance these legal needs against storage costs. We use tiered storage. Hot storage for recent logs, say 90 days, for instant searching. And cold storage, tape or Glacier Cloud, for long-term compliance archiving. Finally, when the time is up, secure disposal is key to limiting liability. As an auditor, you will compare the system settings against the written policy to ensure they match. This timeline visualizes a typical retention strategy. Days 0 to 90 are in hot storage for real-time analysis. From there until year 1, they sit in warm storage. Years 1 to 7 are spent in cold archive for compliance. Finally, at end of life, we execute secure destruction. This tiered approach balances performance, cost, and compliance. To wrap up, let's look at your audit checklist. First, verify logging is actually enabled default settings. Often leave it off. Second, confirm logs are centralized and protected from tampering. Third, review the alert configurations. Is someone actually watching, or are the alerts going into a void? Finally, verify retention. Are you keeping data long enough to satisfy the law? Operational log management is the eyes and ears of IT. Without it, you are flying blind. Thank you for joining this session. Our final diagram is your takeaway checklist. It branches into 4 key questions. Is logging enabled? Is it centralized and secure? Are alerts reviewed? Is retention compliant? All branches feed into the final pass/fail determination of your audit. Use this to guide your next assessment.